Welcome back, guys. We're going to look at take some material off of this part. We'll be drilling some holes, doing some pockets, helix boring, flipping it over, and machining the backside. So stay tuned. So we're going to go up to File, and we're going to change our units to Imperial. So we'll go to Configuration, and don't touch any settings here except for this bottom drop-down bar. So pick inch, and if it says Startup, then we're on the right track. So click OK, and that bottom right-hand scale will show up as the proper units. So if I change it back to metric, you'll see down at the bottom right-hand corner that says metric. So if we go to our tools, it'll bring up some metric tooling, and it's hard to find anything that's imperial tooling. So you'll have to change it back to inch. So just make sure you do that to get it started. So now we're going to set our standard milling machine as mill default. Then we'll go into our tool settings and select these two options. Okay, it'll set up your tools sequentially and warn of any duplicates. Now we're going to change our stock size. In this bottom Z box, we'll set it to 0.125 because we have an 1.25 inch stock, and we're going to take 1/8 of an inch off each side. So I'll click this button here, and that'll show my stock boundary. And you can turn on these settings in your toolpaths toolbar. So go to your top view. This is how I like to draw things. And we'll go up to wireframe and draw a rectangle, 2.5 by 2.5. And we'll anchor it to the center. And if it doesn't go anchor to the center, it will do a positive value on both quadrants linked to the mouse. So if you click that top bar, you can select origin or press O. Now let's make another box where we can specify our hole positions. And we'll set this at origin again. And once again, or press O. And it'll link to the origin. So now we're going to specify our hole diameters at 1/4 inch, and we're going to lock them. So then we can just click on each corner, and it'll maintain the same size. So if I click on this and don't have the lock selected, then I can change it by clicking and dragging and then specifying the number while it's a cyan color. So let's delete this box. That was just reference geometry. I can click on each line, or I can hold down Shift and it selects the whole box, and then press Delete. So now we want to set up a center circle. We set it at 2 inches at the origin, press O, and then a 3/4 inch hole or circle in the middle. Now let's go chamfer the outside box, putting a 1/4 inch chamfer on each corner. So you can select each intersecting line, or you can do chamfer chains. Now for some reason this says decided it's not going to link up, so let's trim it just in case the lines don't match up. And chamfer chains, and you select the outer boundary and click OK. And we have our 1/4 inch specified right there. And we have the chamfered edges. Now you can see that my wireframe is above my stock, and that's because of my excess stock that we're going to machine off. So if I set this at 1/4 inch, it will offset it 1/4 inch above 0. So let's set it at 1/8. So we'll shave off 1/8 from the top and on the bottom, and let's go up to our facing toolpath and pay attention to this box here. It says select to specify stock boundary, or just click OK to use the existing stock that we've defined already. So let's just use the existing stock. Let's go to filter our tools, and we're going to search for 2-inch face mill. Now all of these options are selected because they're blue, so we'll click on None. Click Face Mill to enable it, and you can specify diameter or not. So here we have a list of different sizes of face mills, so let's click number 2. Now as you can see, it's specified as number 1, and we can define our settings. So if we right click and go to Edit Tool, we can edit our defaults by clicking Finalize Properties and changing our standard settings for cutting this specific material. Let's say it's 800 surface feet per minute for mild steel. Okay, we can set our feed per tooth and our different feed rates. So we'll click on Finish, and the defaults show up in the window. Now we'll go to Cut Parameters and pick on Zigzag. We can usually leave the defaults as is. You can play around with this if necessary. And we have stock to leave. We're going to leave it to 0. And you can change between your linear, your high-speed loops, or rapid motions in between. And if you click this toolpath button, it'll show you what it's going to do before you hit render. So I'm changing the options and showing you the different linking between passes. And if you wanted to hide the dialog, you can click that Hide Dialog button, and you can orbit around. And pay attention to that little tooltip box. It gives you instructions. So let's go to Depth Cuts, and we'll set max depth to 100 thou and finish passes. And we'll do Keep Tool Path Down. Then that allows us to not lift up. We'll set our tool height to 2-inch clearance, our full retract, and then our feed plane. And then we have our excess stock, or top of stock is 0.125. And then we want to go to our top of our part, which is 0. Our planes, just to verify that we are in the same orientation as our tool. Turn on our coolant, and we can save this defaults to a file, so every time we go to face, it will make sure that we're using the same settings. Now if you take a look here, we're going 100 thou, and we'll be able to do a finish pass at 10 thou, and we're stepping through, and you can also press S on the keyboard, and then it drops down a little bit further and cuts across without having to wrap it back over to its initial point. So let's rename this tool path, call it facing. So you can do it in 2 different places. And now let's rename the toolpath group. So this will be the top side. So you go to Groups and then Rename. And it's good to keep organization, just because when you get 40 or 50 toolpaths, it gets a little bit daunting. You have these red buttons at the top here that control where your next toolpath will go. We can turn off our toolpath, activate it or deactivate it so it's not too cumbersome. Now let's do a dynamic toolpath. We can also do contour, but sometimes dynamic is a little bit better. And we don't want to use our machining boundaries. We want to set an avoidance boundary. Okay, our machining boundary is going to be this red stock, and we'll use the outside as our strategy, and we'll go around, and if you pick the base of the line, it will go around clockwise. So if you click that red button, you can cancel it or unselect that. So you have to pick the base of the line in order to choose the direction. And you can click that preview chains to show what your toolpath is going to look like. Now let's add another tool. we're going to pick a 3/4 inch bullnose end mill, and we can set our filtering properties to find a 3/4 inch bullnose. So this one's a flat. If we move over and add a bullnose, now we have flat and bullnose end mills showing at 3/4 inch. So click OK, and put in your comments. This will be the roughing the outside. If we right-click and edit our tool, we can go to Finalize Properties and set our feeds and speeds as default. So we'll do 800, we'll do 10,000 feet per tooth, or 5,000 feet per tooth, and we'll set our plunge rate at 50 because we're going on the outside, and rapid at 200. And we can set this to carbide. It doesn't make a difference. So all our settings have changed. So let's go to Cut Parameters, and we'll specify 0.375 outside of the stock. So that just gives it a little bit of room just on the outside. We have our step over at around 10%. We have our arc value, and we're going to leave some value on the walls, but nothing on the floors. Now let's look at percent of tool diameter. That's going to keep your tool down within 300% of the diameter. We'll change our micro lift distance to 0 and our back feed rate to 500 on newer machines. On older machines, you might want to set it to 200. Now let's go up to our depth cuts, and we're going to specify 600 thou deep. We can specify finish for different cuts, but we don't need that. So we can use depth of cut order. You can do it by region or by depth. This is really good for thin walled material. You might want to go with depth. We can go to entry mode with it, which is helix, which we don't really need. So let's set our linking parameters 2 inches above the stock, and we're going to use clearance at the start and end of the operation. We'll set our feed plane to 50 thou, and our top of stock is already 0 because we faced it. Our depth will be an absolute, and we're going to specify the furthest point in the part. So probably around 1 inch, maybe 1.1, but we need something to hold on to. So let's take a look and see what we'll have. We'll check our planes and make sure our coolant is on. We'll save to the defaults file. Click OK, and we'll take a look at this. So we've got 2 cuts, 2 depth cuts at 600 thou, and if we verify using both operations, we will be able to see how much stock is going to be left to hold on to. So click on Stop Conditions, click on Operation Change, and this will stop every time you do a new operation. So it plays, does the facing, and then it pauses for you. And you can adjust your speed slider here, so it pauses, and now we're ready to do our high-speed machining. And you can see how it did that. Keep tool down, it didn't lift up for the facing. That's what we want. So go around this part. 1 cut and then 2 cuts. So we're not holding on by a lot, so let's reduce that down. And we also have a radius on this cutter of about 60 thou. So let's adjust, go back into our parameters, and then linking parameters. And we'll change this to 60 thou. 1 inch and a 1/16. Click OK, and then we'll re-render it, or generate, and then verify, and we'll check and see what kind of stock we have here. So it looks like we've got a little bit more to hold on to, and sometimes you can measure by using this distance button up at the top. In this case, it's just not working for me, so looks like we should be okay. And we're going to collapse this and hide our toolpath. And now we're going to rough out the inside of the pocket. And we're going to just use a pocket toolpath. And we'll click on that linking, and then we'll click OK. We'll go to our tool, and we're going to use the same 3/4 inch bull nose, use the same settings. And our cut parameters, we're going to leave 50 thou on the walls and 10 thou on the floor. We'll go to our roughing and select true spiral. It's good to leave at 50% step over. Sometimes you get cusps. Spiral inside to outside is really good to have. You typically send your chips against the walls. Let's click entry motion. We can select between ramp, helix, and off. And these options are just entry into the stock. So it's always good to have at least 50% of your minimum radius of your cutter, and then 100% is all right. You get your Z clearance, which is 100 thou above, and your XY clearance from the walls. Your plunge angle is probably good to set at 1 degree, depends on the cutter. And you can also center on the entry point, and if all attempts fail, make sure you skip if you have a pocket that is too small versus the cutter. An entry feed rate is for when you go to do your ramp or your helix. So entry feed rate, if it defaults to plunge rate in some cases, and that might be too slow. So select your feed rate and it should ramp in nicely. Let's click on finishing, and we can select our passes based on our finishing. And we can do machine passes only at final depth, and this works well if you have a cutter that is got enough flute for one pass. Let's set our lead in and lead out. And we'll set 25% on both the arc and the entry, and then copy it over to the next part. And then we'll go over to linking parameters and set our defaults that we have been using. So we've got our top of stock, which is already machined, which would be 0. Our depth is 1/4 inch. So we go -1/4 inch, and we check our planes, and then we make sure our coolant is on and save our defaults. Click OK, and now we have a ramping helix into our pocket. Let's rename this toolpath to rough pocket, and we'll use our verify and see how it looks. And it looks like we got some stock to finish up, and it looks like it might be the right depth. So it ramps in and then arcs out, and then does a finish pass on the last. So let's minimize this, and now we're going to start doing some finish machining on the pocket. So let's turn off our tool path, and we need to set up using our circle mill. We can use pocket as well, but we've already done a pocket. So let's try out circle mill. We're going to select the diameter, which would be our large circle, and pay attention to that tooltip. It gives you the instructions for everything. Click OK. Then we click on Tool. We're going to create a new tool. And you can always select a library tool, and it looks like my screen glitched out here. So I'll click my flat end mill. I'm going to use a 1/2 inch. Just verify that I've got a 1 inch in length for flute, and set my cutting parameters. And if I do 0.5 divided by 150, I get a decent chip load per tooth. I've got 4 flutes. My plunge rate is going to be 50. My retract rate is going to be 200. And I'm going to click on Finish. Let's set our comments here. Finish pocket. We'll go to cut parameters. We're going to turn off, leave on walls and floors. We're going to go to our roughing, and this is what's going to open up the pocket floor. So you can change your settings, and we're going to see what it looks like without. So finishing, we can do semi-finish pass or just finish pass, and we're just going to try it out with one, and maybe a spring pass, just to take that little extra deflection off. With our finish passes, we can select final depth, but it's not really going to do much because we haven't specified any depth cuts. We can override our spindle speed and our feed rates for our finish passes. We can do our transitions, and we're going to set our lead in and lead out. So just remember, change a setting, see what it looks like, and then check it out. Change settings necessary. We're going to go to our linking parameters. We'll set as defaults, as normal. Our top of stock is actually going to be 0.24 because we left 10 thou on the floor. Okay, so now it's going to be 50 thou above using the feed plane from our remainder. We'll turn on our coolant. We'll save as defaults. Click OK. And it looks like it's only doing one pass. So let's check it. Let's go back into finishing. And it looks like it should do two passes. I want it to start in the center and arc in. So we're going to change these settings here. Let's backplot, and here we go. It starts from the center, arcs in, goes around, and then back out. So one of those spring passes didn't actually take. So let's go back to parameters, go to finishing. Let's try two finish passes and no spring passes. So let's click OK and see what it does. We'll backplot, and it goes down, in, arcs around, and does two finish passes. Now we need to go in and do our roughing pass because we need to clear out the material that's left over, otherwise it'll cut a ring. So let's go to our roughing, and we can turn off helical entry. We only have 10 thou, and 50 thou or 50% of the cutter is usually pretty good. So we'll backplot it, and now it should go in and clear out the middle portion of that pocket. Do our finish passes, and then arc out. So now we'll turn off the toolpath and collapse it, and now we can do our contour toolpath for the outside portion. So it's important to figure out which direction for climb milling. It leaves a better surface. If you click that red button, the unselect, so make sure you pick the proper side of the line, and that will give you the proper direction for climb milling. So click the front, let's click OK, and we're going to go to Tool, and we're going to use our 1/2 inch flat. We're going to type in Finish Outside, go to Cut Parameters, and we're going to make sure that we have nothing on the walls or the floors. And there's this nice thing called External Corner Break Radius. It will chip away any corner by 5 thou, or whatever is specified. We'll go to Depth Cuts. We don't need it. We'll change our lead in and lead out to 25%. We'll copy it over to the other side. And we have an overlap that we can specify, and that'll just be an overlapping of each arc or lead in and lead out. We'll go to multi-passes. We'll use this later. So let's go to linking parameters, and we'll specify our default parameters. We're going to go down a little bit past the finished part, so 1.0625 in absolute mode. So we'll cut into that radius that we left with the 3/4 inch cutter. We'll check our planes, turn on our coolant, and now we'll save to defaults. Click our OK, and then we can see that there's only one pass. Now let's backplot so we can see the path, and it goes around once. I'd like to do a spring pass, And we'll go into parameters and then multi-passes. We'll turn this on. And we're going to do 2 finish passes at 2 thou. And we'll do final depth or all depth. We're just going straight down. There's no depth cuts. So we'll backplot it again, and it goes around, and then a rapids up, and then around again. Now let's figure out how to get rid of this rapid up motion. Go back to your multi-passes in your parameters and select Keep Tool Down. Click OK. Now if we backplot this once more, it'll go around, then move over to the entry point, and then go around again. And you can see that there's a small overlap, and that would be specified in your lead in and lead out. Let's click OK and collapse, turn off our tool path. Now we can select contour for this hole, or we can select drill. We can also use circle mill, but we've also got helix bore. So let's use helix bore. Select a circle, click OK, and we're going to select our tool. We'll pick the 1/2 inch flat. We're going to knock our feed rate down. Let's put in 25. We'll put in our comment helix, the bore. We'll go down to cut parameters, and we'll start at the center and end at the center. We can specify an overlap as well. And we're going to turn off any stock to leave. We're just going to bore this clean out. We can specify a rough pitch. I usually go about 30 to 50 thou. And we're going to do 1 rough pass, and you can lower your feed rate at the final depth to give it a nice, clean, accurate surface. So let's change that to 40. Go back, and now my feed rate has changed. So let's open up our finish, and we can helix upwardly. Now this isn't necessary for what we're going to do, and we're going to check our tool path, and then we'll go to our linking parameters. And you can see we're going to set our tool parameter, or our linking parameters, the same as all our other defaults. We're going to go a little bit through the piece. So we'll go 1 inch and 1/8, and then we'll specify 50 thou additional depth. So you can do the math in the fields. So we check our tool path, and you can see the helix, and we can change our pitch. So maybe with a smaller cutter and a smaller hole, we might have to adjust. But 50 thou should be safe. And we'll check it again with our finish helix upwardly, and you can see the different path. So I don't need it. We're going to change it to just normal helix down. We have some multi-axis controls, which are new. In 2022, we'll just check our planes and our coolant, and then set our defaults. Then click OK. Now there is another way to do it. We can also do it with a contour toolpath. So let's go up to contour and select this chain. Make sure you pick the right direction. Okay? On the left side of that green arrow is where your tool is going to be. So if you have it pointed north, then you'd have it on the left. If you have it pointed south, it's going to be left of the arrow, which would be the outside of the hole. We'll pick our 1/2 inch flat. We'll specify 40 inches a minute. We go to cut parameters, and we select ramp. We specify a depth of 50 thou, and make sure that you have make pass at final depth, and turn off linearized helixes. We'll make sure that those are 0, and we're going to do a lead in, lead out. We might need to change this. Turn off multipass. We'll change our linking parameters so that we can get all the way through. And turn our top of stock to 0. Check our planes, and there we go. So we don't have any lead in and lead out. So we'll have to make that smaller so it fits in the hole. So change this to 10%. Copy over the settings. And now we have a lead in and lead out. Now let's rename this to ramp bore. So now we have two identical toolpaths that do the same thing, just using different methods. Okay, you can see how similar they are. So now let's do some spot drilling for these corner holes. So let's pick each hole, and we can do point sorting if we had some unique arrangements. So I'll pick this one. So then it can do different assortments. Maybe you need to clear a wall or an island or something. So it's good to have point sorting turned on in certain applications. In this case, we have total clearance on everything, so we don't really need to worry about any huge inefficiencies or tool collisions. So let's click OK. Go to Tool, and we're going to look for a spot drill. So we have a 3/8 spot drill. And if you hover over the buttons, we can find the tool. Type in your diameter, click OK, select this 3/8 spot drill, and we'll edit our feeds and speeds. So go to Edit Tool, Finalize Properties, and change our defaults. So 3/8 divided by 150 gets you a decent chip load. Our feed rate is a little bit quick, so change it to 30. And we'll change our retract rate to 200. And put in our comment, spot drill. Let's go to our cut parameters, and we have a series of different options here. But we're just going to use drill counterbore, and we're going to put in a dwell value. So this will clean up the hole as it pauses at the base, and we're going to put in 100 here, and we can see all these multi-axis. So let's go to clearance and our linking parameters, type in our defaults that we have been. Use clearance only at the start and end of the operation. Now this allows us to clear clamps or just go across to the next hole as fast as we can. If we go to our top of stock, we've got 0, and our depth will be, so we're going to put the chamfer on this hole instead of going around with a contour. So specify 0.3 with our finished diameter, and that gives us our depth. So we can click Add to Depth, and it does a calculation for us. So let's go to tip compensation. That's something you shouldn't check often. And now we have some holes. So these rapid motions, we can change in our linking parameters to use clearance at the start and end of the operation. So now it just rapids up and over to each hole and then back up. So we've spot drilled. We've even counterbored. So now we're copying and pasting this operation and then just changing the actual tool and the depth. So we'll go up to Tool and we'll add a 1/4 inch drill. So we're going to drill the holes, and we're going to change our feeds and speeds. So put in 100. Our feed per tooth is going to be diameter divided by 150. And we'll change our retract rate and click Finish. Our cut parameters, we're going to turn off the dwell, and we're going to peck drill because we have more than 3 times the diameter of the drill. So it's good to specify a peck drilling operation. We can also use chip break, but chip break is a high-speed peck. Go to linking parameters and specify our depth. So we're going to go through the full material. Now we're going to add 50 thou to that. So we break through, and then we're going to add the drill point length. So we end up with 1.125 drill depth. Try not to use chip compensation. It just makes it a little bit more difficult to find your options and your depths. Okay, that always seems to throw me off when I go in and check my depths and wondering why it's going down too far. Turn on a coolant and click OK. So now it looks like the drill point is going right to the bottom of the stock. And let's verify. So we'll rough out the material on the outside, rough out the pocket, finish the outside. There's that corner break in the middle, and it'll run again. And now we're going to spot drill with countersink. And now we're going to drill. And you can see that the holes are already chamfered. So let's go back. And we need to chamfer the inside of the top pocket hole. We'll use a contour toolpath. We're going to pick that chain so that the cutter is on the inside. Go to our tool, pick our spot drill, chamfer pocket. 30 is a good finish speed. We'll go to 2D chamfer here. Specify 30 thou and then a bottom offset. They have to be within half the diameter. So the two added together right now is 80 thou. And we have that 50 thou offset hanging off. We have lots of room for a lead in and lead out. So we can put it a little bit bigger at 10%. And we'll go to linking parameters and make sure that your depth is 0 and your top of stock is 0. Because it does the math. So now we have a toolpath that's going to do the chamfer on the inside. And we'll run this again and make sure that it looks like what we want. And here comes the contour toolpath. Now the only thing we need to do now is flip it over and machine the backside off. So we're going to create a new toolpath group, and we'll call it bottom side. I'm going to turn off my toolpaths. The ghost is to prevent posting of your G-code. So if I put the ghost on, it's not going to generate even in the verify. So let's flip this over and specify our new plane. So we'll go to our planes tab, And we're going to right-click on top and go to Duplicate. Now we're going to rename it to Bottom Side. Click the equal sign to change all your views to that new plane. We'll go -1 inch. And now we have to rotate it. We can either do it on the X or the Y. So we'll go to Rotate Incremental, and we can do it about the Y or the X. So put it on the X, 180 degrees, so now the Z has been rotated, and you'd be flipping your part end over end. Okay, and check that your planes at the bottom right-hand corner match. Let's go back to Toolpaths. We're going to copy our facing toolpath, and then we're going to paste it. Now, really all we need to do is go into our parameters and planes, because this is doing the backside of our part. So click WCS plane, scroll down, select bottom side, and then copy it over to tool plane and construction plane. Click OK, and now it shifts everything up. So now if you click on machine group, it selects all operations, and then we can verify and watch it actually machine that flashing off the backside. And now it'll machine to size. Okay. So pretty simple, but there is another way that if you had more stock hanging off, then you might be able to change to like a 1/2 inch or a 3/4 inch end mill, and you can do dynamic, where it'll actually peel mill the stock off, and you can do high-speed machining. So we specify this at 10% of our step over, and we can increase our speed much more. We're going to leave nothing on the floors, and we'll turn off our depth cuts, and we'll click OK, and now it will high-speed machine the top face with constant cutter engagement. So if you had a good size of material that's needing to come off, you can use it that way rather than going top-down cutting strategies. So it'll come around and it'll cut all that flashing off, which sometimes will damage your inserts. There you go. So now if you want to post your programs, you can select the pocket side toolpath group and click the G1 button. Now this allows you to output your G code, and it says not all operations do you want to post all. We don't want to post all because we don't want to post the opposite side. Now this is asking me to put everything or save the file as the t.nc file. Okay, so here's the program. We have our tool number and our name. So you can either change the name here, or we can right-click and go to Edit Selected Operations, and we can change the NC file name. So we can call this topside. Click OK. We'll change the program number. Change it to 0012. Click OK. And we can even go to Edit Common Parameters. Now this allows you to change your clearance height for all those tool paths, rapid retract, planes, etc. So a really handy tool. So now we need to regenerate our tool paths. And then what we'll do is repost it. So go to G1, use the defaults, and then it gives us our file name that we've specified for the program. So we'll save it, and then open it up in our Code Expert, and there it is. There's our old program, there's our new one. So some of these comments need to go. We don't need them. Now you can also check for your material, and you check that in your tool settings. You pick 4140 or anything like that. So that would automatically change based on that setting, or you could just manually change it here. So 1018 cold rolled mild steel, and we'll delete the file names and the dates, and just to make sure, we'll delete some of this line. Some controllers have issues with too many characters on a line. Now we also have an A-axis. This is for multi-axis, and we also have a tool 1 with an M6 on the same line. On some controllers, it doesn't like this. For instance, a Morisiki, we're going to do a replace, and we're going to search for all A zeros. It's going to clear out all those and replace them with a space. So now let's drop the M6 down from the tool number so that we don't have any errors with certain controllers. And you can use this Tools button to find each tool change. Now, you wouldn't normally have to do this if your post is set properly, but this is a default. So now we're back at the top. We go all the way to the bottom, and we delete X so it doesn't push the table in behind the door, and we can pull our parts off and have them ready for us. Now we'd save, and then we would upload that to a USB drive or use DNC. Now we select our bottom side program, and we can do our posting, but we also have to name it. So let's click Cancel, right click, change NC file name. We'll call this bottom side. Right click again and change the file number. We'll call this 13. And now we'll post it. Click OK, and we save it alongside with our other program. And now we do a little bit of editing. So we'll get rid of our file names and our dates. We check. We've got our material. We're going to change that to 1018 CRMS. We will drop our M6 down and clear out our A0s. Scroll down to the bottom and make sure that the table doesn't go behind the door when the program is done. We'll save it and close that, and you're ready to go. Thanks for watching.